So we're back again. The usual reminder, if you go look at the YouTube video, if you look at under the description under the video, we've got various links. It's got the meeting will be indexed, and it points to the link out to our big index where it's got a composite of all the several years of the meeting index, and you can go there if you want. You can search it up, and you can click on a thing, it'll take you right to the video. And for some reason, YouTube doesn't want that on our main page. If you dig through like the about section or something, you can find that. So anyway, if you, sometime you get curious, go look at the description at the bottom of the video and you can see what's in there. I can't think of any other thing I got to say here. So last week I was saying about these little boards that are LED drivers, and it's a simple one that you put in 2.9 to 6 volts, and then it's just a like a current source driver. So you just hook the LED to the output, and you put in your, like, say, for instance, I can put in 5 volts, and that if the voltage has to be higher than what the LED is, and the thing just seems to work. And I hook those up, and they do seem to work. And it's got a PWM pin, which I've not tested on that board yet. But then a couple days ago, my new ones showed up. I'd ordered some boards from China, and they showed up, and it's got a switching converter. It's basically just is a switching converter, so you can put in up to like 30 volts or something like that, and it converts it down to the voltage the LED needs. It's basically it's a switching supply that's a current source controlled. So again, you just put the LED on the output, and this one is not the first one was adjustable at a pot on the board. You can run that up and down to set the current. This one's not adjustable. It just has resistors soldered on the board to set the current. And the listing said it was a 350 milliamp, or maybe they didn't even tell him. Maybe it just said it was a 1 watt driver. I mean, you're supposed to know that means it's going to put out 350 milliamps. So anyway, I fired it. I hooked it up and put a current meter on the LED, and just put in like 12 volts, and this is pushing 310 milliamps through the LED. So even though somewhere I think it told me it's 350, it's actually 310. I've only tried one board so far. It could be, from board to board, that's just going to vary on how much current the thing's putting out. But beyond that, so it sets it to at this point it's less than whatever the maximum specified for that LED is, so that it's probably more current than I was using before when I was playing around. And it's got a PWM pin on it. So the other thing was, before I move on to the PWM, I played with it, and I had my bench supply set up. I was thinking I should give a demo on this, but of course it's over here on the other table, and I was thinking I could drag out a second computer and log into Zoom and do it that way, but I didn't get around to it for various reasons. So the point was I had a bench supply set up. It's kind of like that one Al has, but mine doesn't show. I think his shows power or something on it. Mine just shows voltage and current. And I could set it to set the voltage wherever I wanted, but then you turn the current knob. If you turn the current knob all the way down, it shuts off. I start turning that up, and it starts. You can watch it, because you come up. I don't remember whether I was doing the voltage or the current, but I got to the point where, yes, I could get the LED to light up, and it showed I could see the current going into the board, and then I could measure the current with a multimeter on the LED. And once you get it up to a point where it wants to run, the current stays at 310 milliamps on the LED no matter what you do. And if you turn it down a lot to where it starts to drop out, if you start turning it down, you'll see the current. Let's see, the current on the power supply starts going up, and when the current there matches the current on the LED, you go any further, then the LED starts to dim down. You start losing current out there. So it's apparently doing what it's supposed to, and you're not supposed to have a bench supply on doing that. So typically you'd hook it up. Say I could hook this right to the battery on I've got a 12-volt battery system on my robot. I could hook it right up to that, and without doing anything else, I can put that voltage on, hook the LED up, and it will light up, and it lights up at that 310 milliamps, which is close to what they specify as the normal rating or the max rating or something for that part. And then the other thing I did before I got around to PWM testing, I had various LEDs, and I was playing with the bench supply. I pulled out a 10 watt white LED, and it has 9 individual chips inside of the thing. Three are in series. There's 3 columns, and each column has 3 LEDs in series. So it takes around 9 volts to light that one up. And I put that on the bench supply and played with it. And I would just I tried lots of things, and I just crank it up to 800 milliamps, and it was real damn bright at that point, and I had to be real careful because I kept I had something I was putting over to diffuse it. So what I'd do, I'd put that over it, and then when I got ready to crank it, I'd put something in front of it to block the view, and then I'd turn the knob up till it said 800 milliamps, and then I'd back away and I had my camera. I was taking pictures of it, so I made sure I wasn't close to it, looking right into it, because that gets ugly real fast if you do that. And then I was playing with things to diffuse it. So the 1 watt LEDs are just they come. You can get them on these little boards like this. This board is actually it's a stamped out piece of aluminum that acts as a heat sink, and somehow they magically figured out how to solder something on top of that aluminum. So I don't know if they put a layer of um, like paint or like solder mask or something on it, and then it's got the aluminum pads around, or it's got pads around the outside you can solder to, so the LED is soldered down to its own pads. And then the in this particular one, the 2 on this side are one's positive, and see I I I painted that one black, and I did that on both ends, so when I was hooking it up I can tell which one is which, so I don't have to figure that out every time. And then on the thing that, so the other 2 pads over here, the one on this side is tied to the one on this side, and it's tied to that pin on the LED. So that's just how it works. So if you wanted to daisy chain them, you could. And then you get more like the RGB LEDs. It's got some number of pads, and you don't have duplicates on that one. You just simply have the wires hook it up to. And then I was saying I had a 10 watt, or yeah, it's a 10 watt white LED. And if we had a better system here, you can see it's got like 9 little chips soldered inside of there, and it's got 3 columns that are tied in parallel, and each column has 3 LEDs in series on each one. So as I say, if you put this on the power supply and you put it, I think it's running about 8.5 volts, even though I was thinking it should be 9. And this is the one I could run it up to 800 milliamps, and it does get warm running 800 milliamps. So what I was trying to do was, I figured, well, I keep thinking, how could I diffuse these things? Because if I could get by with one like this and lay it, say, flat on the thing like this and be able to see it from the side, I thought that would solve a lot of my problems. Right now I've got the one where I've got a metal box, and I've got LEDs attached to each side of it. So my intention was that I could be able to see it from any angle. And if I were thinking a little quicker, I could have pulled up some images from ROS Agriculture where it shows a picture of that, some nice pictures, but I don't have it right now. So I thought, well, if I could lay this one like this, or take the little ones and lay it like this, then if I had some way, this one's got a little dome on the top. They call that, somewhere they refer to it as a bead LED. So it's got a little, like a half hemisphere glued on top of that. And so I was thinking, what can I put over that? And I've tried various things over time. And it turns out, if you have, just a standard, here's one that says bad flickers. This is the one that just quit on me like a week or 2 ago. I was sitting there in my living room and it started flickering, so I replaced it. And I thought, number one, boy, it's really damn heavy. I didn't know why. And I thought, well, if I could get this dome off, I could try that as a diffuser. And it turns out I was able to go around and find a spot, and I was able to get my thumbnail in there and go around like this, just like a can opener. I went around. By the time I got all the way around, boom, it popped right off. So the dome just looks like that. It's just kind of a lightweight plastic, and it's got some kind of a frosted material inside of it. And then I was noticing that the actual light bulb, this happens to be a Polaroid, and it probably was more expensive when I bought it than most stuff. And you can see inside it's got little little printed circuit boards standing vertically. There's 5 of those. And then on top, it's got 6 more, 1, 2, 3, yeah, 6 more LEDs soldered on the top of it. And I have, I think I was looking on Amazon. I think you can buy these individual boards, and I didn't know this is what they're for. But it's got some kind of an aluminum frame here, and I'm guessing it has a transformer down at the bottom. But I haven't taken it apart anymore to find out what that is. So I thought it was curious that this is what was inside of this bulb. And if you look at the numbers on the side, I think this is 12 watts and 800 lumens. And I think a standard like a 60-watt incandescent bulb is 800 lumens as a point of reference. And then I was noticing that here's another one that was in my box that I'd taken the top off once before. This one's really light because the only thing here is it seems to have that board is mechanically fixed down. I think I got some tabs there. And see, this one just has 6 LEDs, and I think that there's a 4-pin chip in the middle that might be a bridge rectifier, or it might be some kind of controller chip. But I just thought it was odd because this one weighs almost nothing. And then the other thing I noticed when I was digging through there, I ran across this one. And this one's really cute. This is just a little little funny little thing here. And I thought, well, maybe that's going to tell me what it is. But it turns out there's like a laser etched around here. I think it says 120 volts, 60 hertz, 1.2 watts, and 70 LM. So I assume it means 70 lumens. So that gives you an idea of how bright it is. And this, this is to replace whatever that, because you could buy incandescent bulbs this size. And it turns out this one I had already taken the top off. So it's just a miniature version of that other dome that I had. And this one, so here's the base of it that screws right into a light socket, and they just simply stuck a little board in there with LEDs on it. And this one, it's not even really attached. I can feel it wiggles. It wiggles around, so there's wires that's soldered to the bottom. It's just kind of flopping around. And I don't know if this one still works or not. It could be I just simply took it apart one time because I wanted the plastic dome off it. So anyway, you take this plastic dome and just lay it. So here's my LED laying on the table. I just put it on top like that, and it cranked the power way up, and it seems to be, from no matter what angle you're looking at, it seems to be lit up really nicely. And then it turns out even the little one like this, putting it on there, that seems to diffuse it also. This one, the big one, will it totally fits inside of the thing like that because you got plenty of room. And this one won't go inside, just right at the point where if you put it on top, it goes over, it covers the whole white part of the LED, but see the metal part, it won't go all the way inside, which may be good. That way I can just put a couple spots of epoxy on there. When you're doing something like it, don't use hot glue because the LEDs get hot and it's going to melt your hot glue and then you're going to be screwed. So if you could, use some kind of epoxy or something, maybe even might even be able to super glue it down. So I'm thinking that this might be a way to do it. And when I was taking pictures of the camera, I had one picture. This thing was sitting on the table, and I took the picture, and there was just a big glow. You couldn't even see the plastic because it was the way the camera was reacting to it. But then I took another picture, and you could see the plastic, and you could see the plastic was lit up brightly. But so again, it comes back to the fact, trying to take pictures of any bright things with a camera, you don't know what the camera is going to do. So that was something I thought of. You could use something like that to diffuse it. And the whole point is, if it's laying sideways like this and you want to see it, well, this one you can get pretty close to. If you get it just so you just about that angle, you can see it really well. But if you're, say, down, it's across the room, and you're down here looking at it, you may not be able to see the light coming out of it. So anyway, this one would definitely be bright enough to be outside. And I thought, well, I've got an RGB one like that. Well, it turns out the RGB ones, even though it's this size and called a 10-watt RGB, but you technically have 3-watt LEDs because it's got 3 red, 3 green, and 3 blue. And they're not, typically they're not all lit up at the same time, or they could be, but the point is they call it a 10-watt, even though it's technically 3-watt LEDs in there. And I was thinking, well, so if I thought, well, if I could just get one of these that's RGB and then put something over the top to replace everything that I had before, that might be a way to go. And so I just did a lot of thought on that. And as I say, you put these domes on, and they seems to seems to diffuse it quite well. And when we start talking about owl stuff, I on his, I was going to suggest you put aluminum foil between each layer, and we could go into why you'd want to do that. And this one, I thought if I put this kind of LED, so it's got the, um, it basically has like maybe a 60-degree uh, view coming out of the thing. I thought if you put this on, it would just simply light, put a spot on the top that would light up. But it seems to give a fairly decent dispersal of even this one that's got the lens on it, and the flat one has no lens. It's basically just the LEDs looking straight up. They poured something like some kind of silicone or something on top of it, and it's got it feels a little bit like silicone, but it seems to be harder than that. But anyway, this is basically just flat, and it's I think they claim it's 120-degree viewing angle or something like that. But so figured if I had something like that and then put something like that to diffuse it, that might be a way to go. And I also realized if I had something flat like this, and if you just had some, like, say, some kind of clear plastic, could you just sit on top of that? And you'd have to figure out what shape would work best. And I thought maybe, go to Christmas decorations or go to the craft store. They might have all kinds of little clear plastic, little pieces of crap that you can just buy and just put one on top. And if that works well, then glue it down on that. And that way that would deflect it enough that probably from the side, would light it up so you can see the thing. So and just over the years, I've been trying to think, how would you diffuse something like that so you can see it? And that's why I ended up, I couldn't figure anything out. So on the one I actually built, it's just got a square box. And then on this front, it's got two LEDs. And on this side, it's got two LEDs on the back. So each side has two LEDs on it that I can light up, at whatever combination I want. But it was a lot of pain to put that together, and a lot of extra wiring I shouldn't have had to do. And if I could get down to a single LED, say a single RGB, and I just ordered some that are RGBW, so it also has a white. So it's got red, green, and blue LEDs, and it's actually got a white LED in it also. So that way, that would give me a choice, four base colors, and it just seems like trying to mix it. Yeah, I don't want to have a whole range of colors to try to figure out what are those colors. So if you got just the base colors, if it's red, that's obvious. If it's green, that's obvious. If it's white, that's obvious. So what I did on my other one, I wanted an orange color, because typical like industrial vehicles have an orange flashing light, and I didn't know how well I could mix the red and the green and maybe a little bit of blue in order to get an orange to come out. Because the other problem is when you're doing this, you got just three bare LEDs and there's no diffusion built into the, like say this one that's a clear one. This one happens to be a white one, so you can see the phosphor layer that they've stuck in there. But on the RGB ones, you can see it's got the clear top, and you can see the multiple LEDs just stuck down to the surface. So when you light them up, you're going to see, if I turned on all three of them, you're going to see the red one and green one and the blue one. And it'd be nice to have some kind of diffuser right over that. And so speaking of that, I realized if I had one of these, the smallest one, to diffuse something, I put that right over my LED. That turns out you can put that over the top, so you get a double diffusion going on. So you just have to be careful you're not cutting down your intensity by doing things like that. Or I thought if you got some cellophane. I know I've seen where they get cellophane. It's got some kind of a metallic coating on it, so it's got kind of a weird, like, iridescent surface or something. And if you get stuff that's crinkly enough, you can just get a sheet of that and just wad it up. So you just got this wadded up piece of cellophane and just stuff it. Say in this case, I can stuff inside of this, or I've got a little plastic like drinking cup. I could put it inside of that, so it wouldn't be diffused, but it would, the crinkly cellophane should scatter the light all over the place. So that's something else I was going to try. I was in Walmart looking at all they're going through their craft aisles, and they had one aisle that they had like tissue paper and stuff like that you could buy, but I didn't see any of the cellophane stuff I was looking for. So back to what I was doing. So I had this white LED, and I'd run it at various intensities and put various diffusers over it. and I haven't hooked up a big RGB LED yet to see what that would do under these circumstances. So that's something I was playing with. And then so back to my other experiments. So I got my new board. It's the switching converter. It's a down converter and it's a current source, and the LEDs on the board will drive 310 milliamps through it. And it's interesting because, if I put enough voltage, say put the 12 volts in I normally be running, if I got this LED, which happens to be a white LED, so it needs about 3 volts to run. I got one looks just like it that's red, and it only needs 2 volts. And then this one takes around 8.5 to 9 volts. And I can just pull out one and swap them out, and it doesn't care. It runs 310 milliamps through whatever I plug into it. So that's another interesting point. If I had to, I could put some of the LEDs in series, like this one has 3 LEDs in series and wants around 8.5 volts. Now, if I was going to do where I had my box with 4 LEDs, if you put 4 LEDs in series and they're 3-volt LEDs, now I'm up to 12 volts and my power supply is around 12 volts. So that's probably not going to work. But I could put 2 in series and another 2 in series, all the same color, and then put those 2 in parallel. And that way I would have 4 LEDs running at 6 volts as opposed to needing 12 volts. So then that would be something I could just swap in and out. So that it amazed me when I realized I could do that with, not without changing the power supply. I'd turn the power off, pull the LED out, put a different one in, and turn it back on. And it, whatever LED I put in there, I could see my current meter said 310 milliamps. So that was interesting to see that. And I didn't do those experiments with my first board, because that one only you have to, since your voltage range is 2.9 to 6 volts, you don't have a lot of options. You can, if you got two red ones that run at 2 volts, I could put 2 of those in series, and that would give me it would be a 4-volt drop, and that would work because I could still crank my input up to 6 volts, and that should still work. And on that one, they tell you put your LEDs in parallel. So the thing is, if you put 2 of them in series, you're still going to get the same amount of current because it's a series circuit. So if I had one red LED run at 310 milliamps, I put another one in series, I'm going to have 2 red LEDs, and they're both going to get 310 milliamps. But if I put them in parallel, now it's still going to work, but now each one will get half. So each one will get about 150 milliamps if I put them in parallel. So just things like that you have to think about when you start playing with this stuff and start hooking it up. So yesterday I finally got around and decided to try a PWM source on the new board, because otherwise I'm pretty much happy with that board. So I just took an Arduino and a potentiometer and stuck them on a board and just wrote code that says read the pot, divide it by 4, and output it to the Arduino analog write function, which just creates a PWM, a software PWM in one of the pins. I hooked that up to it, and that does indeed work. It will go from 0% to 100%, and that's 100% of whatever the current is set at, and the current is set by resistors on the board. And if we get around to Al's board, he's got one that has very few parts on it. It's got one single resistor on the board to set the current, and that one I think that one also will take a PWM. So we'll but as he plays it, we'll find out how that works out. But anyway, I was able to put a PWM into it. The only thing I've noticed so far is if I get the intensity down below about half of the total, the thing starts to flicker a little bit. And I don't know if that's coming from something I'm doing on the Arduino, or if the voltage coming from my pot, or it's I've got a 4-inch piece of wire between the two. I wouldn't think that would be a problem. Now they're sharing grounds at various points, so it could be my wiring, just the way I've laid it out. And I've only tried one board. It could be if I just pull out another board and wire it up, it may act a little bit different. So, but in general, that it looks like one of those boards, say one of those boards per, if I have these kind of LEDs, that should work, and then I could control each one individually. Or if I have, I've got some like this that, as I said, the last ones I bought are red, green, blue, and white, all in the same package. So I'd have 8 wires coming off this thing, and then I'd wire up 4 of those controller boards to it. And then I could just go in, and by controlling the PWM in each one, I can either turn them on and turn them all the way on or all the way off. Or we're probably going to be having noises today. I don't know if you can hear that. So if I put four driver boards on that, and then I just bring out the PWM lines, I can run those off of whatever I want to make that work. So, and the other thing is these boards, both of the boards I've got are small enough. You could put them. I don't know if they'd fit inside of this or not, but you could put this on a little base, little square base down here. You can put all your driver boards right there and put your LEDs so they're shining up through here, and then basically you just run your vehicle power up into it. So I run my 12 volt and ground up into this box to run the thing, and then bring the PWM lines out. Or I could even put like an Arduino or something right in the bottom box and just feed it with a USB cable coming into it to talk to it, and then just have the vehicle power to power my LEDs. And so that it seems, that you got various options there on how to do that stuff. Otherwise, I can, have the box up on top and you just have like 3 feet of wire that come down into the bottom. That's why mine is set up right now. I've got all my LEDs up on top wired together, and then the cable comes down and goes into my battery box down the bottom. That's where I've got all my currently I've got an LED and a current limiting resistor and a MOSFET switch. And then that is attached to one of those little PWM boards like Bob found. He's using that to run his RC servos, and Al now has one to run his RC servos. At one point, Bob had 2 of those hooked up, and that way you can run one of them at 60 hertz for the RC servos and run the second one at a higher frequency if you're trying to control lights or motors or whatever you want. So that's another option on that. So again, once you get the PWM signal, get to that point, you can hook it right to a microcontroller that generates PWM, or hook it up one of these PWM boards that's built just to do that. So you got lots of options on that too. And if you just want it to flash and don't care about the intensity, you don't have to hook it to a PWM. You can still switch it the same way, and everybody should still be happy. And let's see, we looked at, so I should go ahead and tear this apart and see what's in it for power and everything. I should look on Amazon again to see, just buying those little boards, but I'm not sure there's really a lot of advantage to that as opposed to, just getting something like this and being done with it. So, the other thing I was pointing out, I may have already said this, I'll say it again. So you buy this one, it says that's a white 10-watt LED. And since these LEDs are all connected in a series parallel combination, when you put power on this, yes, you can drive this up to 10 watts. But if it's an RGB one, and you got 3. So before I was just interrupted by that lawnmower, I was saying that, if you got the 10-watt white LED and you put enough power through it, you can indeed drive it at 10 watts, and it's really damn bright. But if you get the one that's shaped like this, and it's called a 10-watt RGB, you've actually got 3 watt strings inside of it. So so even though they call it a 10-watt LED, you technically got a 3-watt red, a 3-watt blue, and a 3-watt green. So that's something to be aware of when you're looking at listings for this stuff. And also on this size of one, I think it was the RGB ones that were this size. Again, they were saying it's a what was they're calling them, they say it's a 1-watt RGB. In other places they call it a 3-watt RGB because you've got 3 1-watt ones in it. And so you got to be careful on that too. You got to, no matter what the title of the listing says, you got to go through and figure out what are they really trying to tell me here. So so you have 2 identical ones, and somebody might call that a 1-watt RGB, and somebody might call it a 3-watt RGB. And again, you just have to use your head and say, what's really inside of there and how you driving that. So that's just something else I ran across that you have to watch for. So other than that's pretty much what I've been doing. And I was going to set up a demo here, but I realized that the demo's on this table over here. And I thought what I should do is get a second computer set up and there's a second camera. And that way I could just say, okay, here, let me go over to the other table, and then I can just log in from that one and show my demo. And when I'm done, I can come back to this computer. So that's something I should work on. I should work on that for next week, and then try to get my set up so I can do my demo stuff. So other than that, I don't think I have anything else to report. Oh, the thing was, I ordered those parts. ordered that second driver board, I looked on Amazon, and boy, a whole bunch of them showed up, but none of them were from the United States. They all wanted to come directly from China. And I didn't want to order stuff from China because it said it kept saying, well, it's going to show up between September 30th and October 8th. So it was going to be like 3 or 4 weeks from the time when I was trying to order the thing. And so I thought, well, let me go look on eBay. Well, I got the same problem on eBay. It's you can get all the same stuff, but again, it all comes from China. I couldn't find anything in the United States. So I finally just broke down and said, okay, give me 10 boards for $11. And I had to pay $5.70 shipping. And that's where it said it's going to cost you, or it's going to show up between September 30th and October 8th. Well, it turns out magically it showed up on September 29th. So it showed up one day earlier than what they told me. So that worked out for me. So I've been playing with that. That was what was that, Monday? So I've had several days to play with that. I've hooked it up, and they seem to work, and I'm fairly happy with them. So that's kind of how that went. And I guess when I'm done, I last week I put the links out to my 2 boards that I got, so I could do that again this time. I can put up the links to those 2 boards, and that's all I can think of that I need to document for my stuff. So I think I'm done babbling for the moment. Oh, and they're supposed to test the fire alarm today. If those go off, I'll pause it again. So we'll see what happens on that. So I guess I'm done, and I'll turn it over to Al.
Just a couple things to share. Let's see if we go to, well, how did I get back to that files thing? Oh, there it is. That's clever.
And also notice, you saw the thing where you click on and say all, and it shows you all the images.
So this is a screenshot of my TKInter menu. I mean, this happens to be the desktop of my Raspberry Pi that would ultimately drive the tractor. So just figured out how to make the biggest part of the video and have the steering control on the bottom with presets and then a slider bar, which is getting, I think, pretty close to being usable. And then I also added this telemetry data over here, and so it shows the RTK fix and the heading. Those are the only 2 that are actually live. These are just placeholders at the moment, so I'm not feeding it any data, emergency stop, and then speed control. So again, presets there. So I'm making decent progress on.
Say, Al,
Go ahead, Bob.
can you explain how you made that menu on the right to show up on your screen?
Yeah, this is Python code, and it's using the GUI that comes built in with, I don't know if it's Ubuntu or RPi or what, called TKInter, TKInter. So I haven't posted the code yet. Let's see how would I get to it from here? I can show you the code.
No, that is not, sorry, I'm just, so you use Tinker?
It's TKInter.
Oh, okay.
And well, it's Python and a TKInter library for the actual graphical user interface.
Okay, good. I didn't mean to interrupt.
No, that's fine. That's a good question. So that's one thing just to mention. The other thing, I guess I'll start with the last part of the story. So this is, I mean, Jeff and I are in a similar position of trying to figure out what we want to do with LEDs, I happen to have this RGB LED, and it's just the three colors. So red, green, and blue. This happens to be the circuit that I was testing to drive a blue. I have some other boards to try to figure out how to make them work. But I was just trying to figure out how do I do it if I just use a series of resistors and this NPN transistor. So I do have it, driving a base blue, and I just had a video of what that looks like out there on, and it was just the Arduino is turning off and on the NPN, and this happens to be off. You can see my desktop power is at 5 volts, and when I turn it on, it comes up to 0.2 amps or 1 watt. Now the moral of the story is, will this be bright enough to see when I'm outside? So that's really what I'm driving towards, is testing this outside. And this is ultimately, I'd have 4 colors here: red, yellow, green, and blue. And as Jeff said, there's ways to keep this light from bleeding over.
Yes, my thought on that is if you go back to that picture, or that will work right there too. If you put on the top of, oh yeah, I'd say put it on the bottom of each one, cut a piece of aluminum foil, and aluminum foil, one side is shiny, one's kind of dull. I have it so the shiny one is out, and just have it so so as the LED is shining up, it's shining up against that aluminum foil. And number one, that'll keep it from bleeding from one level to the next.
Right.
And then secondly, it's going to force all the light to go out the side. It's going to hit the top and bounce around. So you could even put a sheet of aluminum foil both on the top and the bottom of each one of those plates. And that way, if you got on the top and it's bouncing back, it's going to hit the aluminum foil on the bottom, and there should be enough. I suppose you could even crinkle up your aluminum foil and then put it in. That way, it would also scatter the light more as it reflects it. But I'm thinking that would work. So the very top piece, that plastic piece on the top, you can put aluminum foil on that too, because your column, you've got a gap between that top plate and the top plate on your total column. So, but again, just do that to to contain the light and hopefully make it come out the sides better.
So this was, I bought this slide off of Amazon. I think it was $25. This was the guts of it. But in testing this, these LEDs were not bright enough. So this is all an attempt to get something that's bright enough to be outside. This is just a simple 3D printed thing to figure out my sizing and whatnot. So that's where I'm at with that. A couple of other tests out there, and then Jeff found I also have this board that I haven't tested yet, and Jeff found the manual for that, and it's in here. It's got either a switch or a PWM input. And then so if I'm going to use this, how I'm going to use this, I haven't decided yet. So at the moment, I've got sort of this approach to driving the LED, or my simple NPN resistor homebrew approach. So I got to think through which approach I want to use. I think that's it for me. Over to you, Bob. Jeff, you're on mute.
Okay.
Oh, so let me interject here a moment. If you go back to that manual you just had,
On my way.
and if you scroll down the second page there, see that little chart right there. Or first of all, it says a limit maximum output current says I out equals 0.2 divided by RCS, and they show that resistor on the board. You got the little table on the right saying here's different values which give you different amounts of current. And if you when you get a chance, look at your board and say, does your resistor say 1R00 like this one does? Or does it say something else on it? And the thing is, if you go look that up on, say, go to the internet and say surface mount resistor 1R00, it's going to back and tell you that's a 1 ohm resistor. So if you look at your chart there, it says with that value of 1 ohm, it's going to give you 200 milliamps. So if that's what's on your board, your boards are going to put out 200 milliamps. Whereas that one board I have is putting out 310 milliamps. So you would have an option on that. You could unsolder that, or you could get another resistor and solder on top in parallel if you wanted to increase your current.
It says R560.
Okay, so you'd have to have got the internet and say SMT or surface mount resistor and type that string in and see if sometimes they'll give you a little chart, tell you if it says, oh, if it's in this combination, blah blah blah. So it could be. See, if you look at the chart there where it says a 0.58 is 350 milliamps, and if yours says a 5.6 in it, it's probably 0.56 ohms. So yours is probably set close to 350 milliamps.
Yeah, I just posted a picture of it on Slack. I don't know if that'll come up yet or not. Let's see. Huh. Well, at least I attempted to post a picture, and there it is.
Yeah, so it's probably a 0.56 ohms, and so it's probably you could probably get real close to 350 milliamps from this board. And then I assume the PWM will work in this. I dug through all the actual data sheet. Somewhere I posted the link to the data sheet too. That's in that big long thing I posted. And so the data sheet will tell you basically this chip is slightly different from another one you can buy, and the other one has a pot and a resistor that lets you manually set the current, but then they have the PWM just overrides that, so it's just going to add more confusion. So this one, your board is set to 350 milliamps, and then the PWM should let you vary that 0 to 100% of that value. So once you get that put on there, without modifying the board at all, you should just be able to change the PWM and make the thing work. Oh, that's the other thing I wanted to ask. I put that in that big thing that I wrote up. And do you plan to just flash your LEDs, or do you want to be able to control the intensity of them through software?
On off flash, that'd be about it.
Because I noticed you said somewhere that on your thing you wrote up, you said the base of the transistor was going to go to the GPIO pin on your Raspberry Pi, and I thought, well, that as Bob found out, you can't get a decent PWM out of a Raspberry Pi, and so keep in mind you should be able to get dimming for free if you just hook it up to a PWM pin as opposed to a straight digital pin. And even if it's a PWM pin, you can still make it flash on and off, but that gives you the added advantage. You decide you don't want it at 350 milliamps, which your LED might get hot at that, or whatever. For whatever reason, again, you can get the dimming for free if you connect it to a PWM pin. I question back to you. You showed that picture you got on the screen right now where you're showing the Arduino flashing that blue LED. Have you checked the transistor to see if the transistor is getting warm when you do that?
Yes. when I used something other than when I used a 1/4 watt or 1/2 watt resistor here, it would get definitely hot. So I'm up to a 1 watt resistor, and it's not, you know, if I let it sit there for 5 minutes, I can still touch it. It's not glowing red or anything. And these two resistors don't get, they're just 1/4 watt or 1/2 watt, and they're not getting hot.
What about your transistor?
Haven't touched that. Sorry. Yeah, that's what you asked about. I was thinking resistors. I haven't touched that, so I don't know.
You have to worry about all of those things. And again, you know, keep track of your LED to see how hot it gets at various currents you're driving it at, especially stuck down to that 3D printed stuff, because I assume if you get that 3D printed plastic hot, it's going to melt too. So,
Right, it definitely would melt.
and that's another thing, you know, don't hot glue your any of your hot parts down to something, because that's going to melt the hot glue and thing is going to start moving around on you. So that's just more things to think about and check. Oh, so back to the concept. If you do want a PWM and you do want to run, so first of all, you connect it right to a microcontroller board. You know, anything that's a small microcontroller like an Arduino or a Teensy or one of those little ARM boards. You know, those will have real PWM. The Arduino stuff is a software PWM, and if you play around hard enough, you can get 1 or 2 hardware PWMs out of that. And the software ones run at like 500 hertz, and they got a range of 0 to 255. If you set up the hardware ones, and you have to look at it, because usually on the real Arduinos, it'll say, oh, you can do like 2 pins with hardware PWM. So you can do it that way. And if you get something like an Arduino Mega, it's probably got you can probably get lots of PWM out of that. So anyway, you just hook it up to a microcontroller like that, and on directly off a Raspberry Pi, it might have like 1 or 2 physical PWM pins, and then otherwise it might do software PWM. But as Bob found out, since you're running Linux, your timing's not exact, and I don't remember what the other problem was. That for some reason, your time is not exact, and things are going to jitter on you. So that's a reason not to connect it directly to a Raspberry Pi. And then as Bob did, he got that little PWM board and hooked up to the Raspberry Pi, and decided that gives him a nice stable PWM. And I think you've duplicated that same setup, so you know how that works. And then, but the data sheets for all these LED drivers, they seem to say use a PWM between like 100 hertz and like 2K hertz or something. And I don't know if it better. One guy on a video on YouTube said, "Oh, it has this big range." He decided 180 hertz is what he wanted to run his at, and I'm not sure why, but that's what he didn't go into that. So the thing is, your current board to run your RC servos is set at 60 hertz, which is below that 100 hertz limit that they gave you. It could be it would still run it or it could be it would still work at 60 hertz, but it might start to flicker or something. So you could add a second board on, and you can consult Bob on that. Basically, you can either put the 2 boards in series. You know, it's got on, say, the left side of the board, it's got your
Yep.
plus your VCC and ground and I squared C pins, and the other end of the board, it's got outputs of those. So you can put the 2 boards end to end and just solder 2 boards, daisy chain the boards together there. But then you have to go into your second board and change the address of it. And I think you either put a resistor on or take a resistor off. And
Make a
again,
solder bridge.
okay, there you go. So consult with Bob if you get that far, because he knows how to do that. And do you have a preferred address that you picked, or you just picked one of them? And that's a question to Bob. When you
Oh,
did your second board,
there's, I forget how many pads there are, but for each address, your first board, you don't have to solder anything. Second board, you take the first solder bridge. And so each board after that, you just keep doing solder bridges. And it's in the upper right corner. You just bridge them with solder.
okay. And when you do that, that just generates a different address for that I squared
Yeah,
C.
yeah,
And you look at the documentation, it should tell you, you know, if you solder this one, it should give you this address.
exactly.
And if you can't figure it out from that, there's a way under Linux, you can say, show me all the I squared C addresses, and they'll give you a little chart of all 256 addresses, and they'll tell you which ones are
Yeah,
responding to you. So that's another way. But when you're playing with I squared C stuff, that's handy to know about that. I can't think of what that's called, but
yeah.
it's not that hard to find. So anyway, so my point was, if you decide you do want to get PWM for your LEDs, you know that so you got several options there. Either just put a microcontroller, or you can and it seemed to be working with the software 500 hertz PWM coming out of my Arduino Nano, and it might run better if I'd put a run from a hardware one or change the frequency. I can't change the frequency on that software one, but you know, if I could switch to one of my ARM boards and probably get lots of, or I can get several hardware PWMs out of that, so that, you know, if I had to, I could do that. Or again, back to that little external PWM board that can solve your problems too.
Yeah, right now I'm just trying to think through how much additional hardware do I want to drive these four lights. So it's either the boards like you're talking about or the resistors and transistors. So no easy answer, it doesn't seem like.
And if you read through that whole thing I posted, I gave you various suggestions. And one thing I suggested was, rather than put your LEDs right on your, you could put the LEDs right on the LED, or put your resistors right on the LED modules. But that means if you want to change it, you have to tear the whole thing apart and then take the resistors off and put the new resistors on. Or if you just run the wires out, I gave some, you know, I was talking about logistics, and it turns out if you just run one power wire into the, well, if you're doing the resistor method that you got right now, run a single power wire in, tie your anodes together, and then bring all the cathodes out as separate wires. And then you can put your resistors you're playing with, put them on your driver board. So you can have your transistors and those resistors all in one spot. So you don't have to tear the thing apart every time you want to change the values. You could even just do that on a proto board, you know, to start with, just to verify
Right.
all that's working. But if you switch over, I put a big butt. I put a big butt right in the middle of that thing. I was even gonna put a comment about look at the big butt on that guy or something. I didn't. I just put butt in capital letters. I said, if you switch to those little driver boards, now you have to bring both wires out and hook them up to the driver. You can't just tie. Theoretically, I was looking at, you probably can, because I think the grounds on those are probably just tied together. So you could probably just tie all the grounds together, and just the source, the drive pin coming out of that board, run it in to hook up to your LEDs. But it may cause some weird interference, like when I was getting that flickering, it would do something funny like that. So if you get that far and want to hear more about that, we can look into that. But otherwise, the simplest thing would be bring out, two wires for each LED you want to run, and then have the little driver boards, bolted to another plate or something. Or those are small enough, you could actually put those right inside what you got right now. You could probably put the board right next to the LED inside of it, and just that way you still have to run your vehicle power in, which is daisy chain from level to level to run each board, and then just bring your PWM wire out to wherever you want. To turn them on and off. So that's, just more. And I wrote all that stuff up. And a couple of things, one of the things at the bottom, I said, oh, by the way, how did you want to do this? And when you answer it, I'd give you more options. And so I try to figure out what they were. We could probably pull it up and look at it, but well, here it is right here. What's this say? It said, when you're playing, trying to get your yellow color. Did you try just turning on the red and the green at the same time at equal intensities? And what does that look like if you do that?
When you say intensity, do you mean with the same resistor?
Yeah. Because what I'm thinking ahead here and say, if you use those driver boards and you don't have the option to, conveniently change those without changing resistors on the boards. But if you bring those out as PWM, then you could still go back and change your to mix colors, you can run those up and down. So that would be another reason to use PWM in those. But I'm just curious, you turn them both on the same amount, does that look yellow, or does it look green, or does it look red, or somewhere in between? Did you do that?
Yeah, I never had them. I never had them at exactly the same number. But it was always green until I got up to 100 ohms. So to
Okay.
get a yellow, I had to go, I think I started at 10 and 4.7, and I forgot the exact combinations that I ran through, but it was green was my prevailing color until I got up to 100 ohms.
Okay. So if you put those driver boards on and you got, see, you would have to use 5 driver boards here, because in order to control that red and green separately on that one, you're going to require separate boards. So then, of your 4 LEDs there, you're going to need 4 drivers for that, and the one has actually 2 LEDs you're using. So you would need a total of 5 driver boards. And then, as I say, if you bring that PWM out, now you can go 0 to 100%. So now you can run the colors up and down to get just the right shade of yellow coming out of the thing.
Mm-hmm. That'd be nice to have that variability.
So that's just something that was one of the things I was asking about. And the other one was, and I guess your answer was no, it's always going to be green if you don't back it way off. It said something about go to control. Oh, the last question was, I was saying, do you want to do PWM, or you just want to flash them? And I said, based on your answer there, we could talk about things. We pretty much just went over that. But yes, that is a point that, if you do PWM, you can run them all up and down if you want. So it's back to this concept. If you want to put a light sensor on the top of your robot, just to read ambient light, so if you're out in the bright sunlight, it'll crank them up all the way, set your PWM to max. And if you're inside, you might want to back them down to 10% or something like that. So they're not blinding everybody inside of a house. Now, this look really nice at night. If you crank them up to full power and drive around in the dark at night, that'd really be spooky looking. But yeah, you could also at that point you say, okay, it's dark outside, so it'll back them way down, so you can still see them blinking, but you're not blinding everybody at night.
I could spend until Christmas farting around with this damn light instead of just getting out and doing my testing. Bob is already in his driveway testing, and I'm sitting here farting around with his light. I got to catch up with Bob. Speaking of Bob, over to you, Bob.
Oh, okay. I'll share screen pictures. There's share button, screen, start broadcast. Should be coming up pretty soon. Huh. 2, 1, okay. Okay, now I'll go to,
You're getting close. It says you are sharing screen.
Okay. Now I want to, there's the pictures. Okay. This week I was trying to consolidate all my Jeep pictures, and I found back in the day how I put those wheels together. There it is right in the middle. I found a couple of ATV tires in the ditch, so I grabbed those and then cut the sidewalls out. And then when I started, I put 3 screws or a couple of screws across one end, and then tried wrapping it around. But then I had to use straps to bring it closer together. And then as it got closer together, I had to keep trimming a little bit of tire. So by the time it was completely snug, that's when I put a couple of straps across it. let's see, where's the straps at? Oh, here they are. And then working between the straps, I put in some screws. Okay, so there's the end product when it was all done.
Really lucky you found those ATV tires. That's what I
Yeah.
noticed when you were driving. Getting back up on the concrete was easy for
Yeah.
you. And I remember messing around with these power wheels before. It would have just sat there and
Yeah,
spun.
royal pain. I got one video. Yeah, they're a 3-minute video. Notice the casters when it starts moving. There's a lot of slop in them. And at certain times, I think they're interfering with the drive wheels trying to turn. And I had forgotten how I put that back together or put it together in the first place. And I just used some bolts that I had for farm machinery. And I cranked down the nuts and I thought, oh, this is good. Well, I didn't realize that I ran out of thread. So I was just bucking up against the shoulder of the bolt. So now I've just taken apart and added more washers. So now it's really tight. Let's see, there's that flat bar. Let's see. Oh, yeah. Where's that sucker? So to help stabilize that, I put that's how it was assembled. Those two bolts were down tight, but it was a matter of just running out of thread. So then I just put in a piece of wood and cinched down as hard as I could, and that's helped quite a bit. I don't quite have the metal inventory I had back on the farm. I had ordered to get rid of it, which I did. So the other issue I noticed was the motors on both sides are flapping around a little bit. So I've got to put some strap across that and hold it tighter. The other issue is I had to go to 3 batteries, and eventually I want to get a larger 12-volt battery, like for your lawnmowers. But right now this seems to be working. But I want to put the extra battery, all the batteries on this one table. But then it gets too heavy. So I did scrounge around. I have some aluminum angle. So I'll cut some kind of bumpers to go across the front of it and around them to hold them in place so they aren't sliding around. And then maybe find one of those little bungee cords and stretch over the top. But I want to get to the point where I can just disconnect some Molex connectors and pull the batteries out quickly, kind of like your electric tools with the rechargeable batteries.
So why did you add a third battery?
Let's see. I was having problems. One battery was for the electronics, and then the other one was for the PCA 9685, because I had to have 2 different power supplies, because I tried running it off of one and it wasn't working very good. So I separate them.
Well,
Now
it seems to me you can put 2 power supplies on a single battery. You shouldn't have to add a whole new battery. So
okay,
you might try that sometime, see what that does. That
Yeah.
way it gets rid of that much weight.
yeah, I'll do that. I'll try that next. There's the connectors I bought to connect and disconnect between the 2 different chassis. And then my wife came up, and I and said, look at this, why don't you make that into a robot? I said, oh, I'd love to play with Omni wheels, but they're kind of pricey, and I don't know if I'll get diverted too much. So then we started brainstorming and taking the base out, which way, up or down, and then the seat of that thing fits perfectly inside the Jeep. That's why I've got it. So one idea we had brainstorming was mount the spindle at the bed, and I could either leave this as a permanent fixed place, or if I don't have anything else better to do and a whole bunch of money, maybe I can make it into a turret affair. But you can see where the beast just more or less sits in the chair. The other thing was I ordered this double pole, double throw, because I only have 2 battery chargers. And so I thought I'd separate them and not gang them together like this, but have one supply coming in on the left side of the terminal, and then the other battery coming in on the right side. That way, when I flip, I can choose between chargers. So when the switch is one way, I don't know how. I wish I could use my pointer, but so in the neutral position, everything is off. So if I flip it one way, it'll connect 2 chargers. If I flip it the other way, then it would charge another charger if I need it. That's about it. Yeah, that's about it. On that outside chair, that's just it's got to be pretty cold outside before I work on that one. So that's
back to your video. You were showing the thing driving around. You said your castor wheels are acting funny. Well, first of all, yes, castor wheels will just simply do that. And as you try to, go from forward to backward, the castor wheel has to spin around, and that will, your vehicle, if you don't have enough weight and enough traction, yes, it will. So now watch when you go the other direction here.
Yeah.
As they spin around, you'll see your vehicle kind of jerks one way or the other.
Right.
You can minimize that by getting the castor wheels, the part that turns. If you get that exactly vertical, it'll minimize that. And what you could do is you could cut, like, say, a piece of plywood or something, just cut some kind of shim and bolt it between the plastic frame and that metal plate on there. Because if you raise the front end up, that'll make those a little more vertical.
Okay.
And then by doing it either, like 1/4-inch plywood or 1/2-inch plywood, whatever you got kicking around, you can cut different things and bolt them in between there, and that way you can change the height. I know back on the original video where you're talking about this the first time, you were saying something about when you add the treads on your back tires, that was going to make the back higher, and that'll compensate for that. So no matter where your back is, you can now move the front up and down. You can't really lower it anymore unless you do major things, but you can raise it by just putting shims in there.
Yeah, I think I'll try that one too. So that's.
But yes, castor wheels will affect the whole thing as they spin around like that. But you can minimize it if you get those adjusted.
Right. One suggestion that I was given was just use one castor wheel. I don't know if that'd be stable enough going over the different kinds of ground.
Yeah, it will sit much better if you got four wheels on there. The other problem is if you get on uneven ground, you got 4 contact points. Something is going to have to give, and it could be, if you get the point where one of your back tires isn't the one that has the preferred traction, it'll spin on you. But You know, just for the moment, just go with it and see what happens. And
Yeah, I'll try that shim idea. And
have you tried driving this to the grass to see how it works?
no, not yet. I wanted to get it off the. I want to fix that front end first, or that castor wheel end. So I'll do that this week.
Okay.
And which brings up another issue. I was outside. It was real hard to look at the laptop screen to see what the camera was seeing. And then, but when I got into the shade, I noticed I had some latency, like 3 to 4 seconds between when the camera took the picture until I got it. So I started researching how to reduce that, and I ran across something called WebRTC. It's supposed to be a real time, and it's supposed to be faster than the way I was doing it. But at first glance, it looks pretty complicated. It's going to take some kind of a learning curve. Now, what I have found is that the WebRTC per se won't work on the Raspberry Pi, but there's another module or some packet that will help make it work on a Raspberry Pi, but I have to do more research on that. But supposedly this one is real-time communication. So I don't know. That's another cold weather project.
Are you trying to feed your camera image directly across the network, or you just displaying the camera image on your virtual screen on your Raspberry Pi and then just sharing the screen? I was thinking is that what Owl is doing?
Let's see, the camera goes into the Raspberry Pi. And yeah, I was using No Machine to look on the Raspberry Pi.
So basically, you fired up cheese or something, and
Yeah, cheese on the
image.
Raspberry Pi, and then use No Machine to look at what was going on the Raspberry Pi. The No Machine was on my laptop, so I think it was probably going through our house network.
So if you're just viewing the screen, it could be you need to look at the No Machine stuff and see if you can figure out how to speed that up.
Yeah.
You know,
Yeah.
other things you can do, you can reduce the size of your virtual screen, you know, your desktop, make that smaller so you got less data to send back and forth. And
Okay.
your image that you're putting on the screen from your camera, if you make that window smaller, that'll probably run faster. And
Yeah.
it could even be, you know, maybe adjust the resolution of your camera coming in. So there's various things you can do to just make the camera work faster to display on your screen, but then No Machine is trying to move,
Yeah.
you know, the images of your thing back and forth.
Yeah, I haven't looked at the frame rates or any of the pixel counts yet. So that'd be a good one.
So but that's the way to think about it. You know, your camera is putting stuff right on your Raspberry Pi screen, and you want that to be, you know, usable at that point. And then when you hook up No Machine, it's going to be moving your images back and forth. So
Yeah.
so that's something you can look at. And it could be even in No Machine, you might be to change its frame rate or something and say, you know, set instead of saying 30 frames a second, maybe go set it down to 10 frames a second. So there might be settings there that will just speed up the whole thing too.
Yeah.
But that gives you plenty to look at there.
Oh yeah. So at this point, I'm just throwing stuff at the wall to see what works.
For me, Bob, the first thing that I wanted to do was to see if that delay was at what I'll call the control layer, or was it at the video layer? So if I could hit a button and I knew the servo was moving basically as fast as I could hit the button, then I knew the control layer, there wasn't any latency in the control layer And then I could say, you know, it was the video layer that was delayed for whatever reason. So
Yeah, I didn't operate the servos. I just tried to move the robot and see there was a significant 3 to 4 second delay. Like the frames couldn't go fast enough to catch up in real time.
yeah, so I mean, there's not a whole lot of data to go on. So it's again, I'm suggesting you want to try to figure out, is it an overall network? You know, both the control layer and the video is delayed, or is it just the video that's delayed?
Sure.
Another test on that, next time you have your controller next to your big TV, you know, plug the TV directly into the Raspberry Pi, and then, you know, stand in front of the camera and go like this and see if is it real time on your TV, or is there a delay there? You could even have, you know, just between your camera and showing up on the screen there, it could be there's a slight amount of delay there. But if the camera is putting it right on the TV screen, which would be your desktop, and that's if that's running in real time, that's good. And then you have to figure out how can you read your desktop at a faster rate to get the data to move across.
Because if it only happens when you're out in your yard, I mean, my spidey sense says, oh, it could be an overall network
Sure.
issue.
Yep.
Because I don't know, the further the more distance you're getting in your network, the more it could be an issue.
Yeah. Well, lots of things to work on.
But you're in the yard driving around. That's awesome.
Yeah. Well, that's all I got.
I'm all set too.
Okay, I think I was trying to think if it prompted me, and I don't think it did. So I guess we're done for this week.